Dear students, like and subscribe my channel. This algorithm is Warshalls algorithm. For your exam, Warshalls algorithm or floats algorithm, one example is important. This example it will ask for 8 to 10 marks. In this Warshalls algorithm, to compute the transitive closure for the graph as shown below. Graph is given in this Warshalls algorithm. Graph will be given directed graph. All edges are directed. From this graph in Warshalls algorithm, we have to find transitive closure. Means we have to find one vertex to another vertex. If direct or with or without intermediate, if vertex is there, we have to write 1, otherwise we have to write 0. Within this first step, if graph is given, then convert into adjacent matrix. If adjacent matrix is given, then convert into graph. Here, within this example, graph is given. If graph is given, then convert into adjacency matrix. And if you want to convert into adjacency matrix, in this example, if total number of vertices 4, means if n equal to 4, then graph size should be n into n, means 4 by 4. By default, this is A, B, C, then D. A, B, C, D. Means convert this graph into matrix. First A to A, edge is not there, right? But this is 0. A to B, one edge is there, then this is 1. A to B edge is there. A to C edge is there, no. Then A to D, no. Thus this is 0, 0. Next from B, B to A edge is there, no. 0. B to B, 0. B to C, 0. B to D, only 1 is there. B to D. And this is 1. Next from C, C to A, C to B, C to D, C to C. There is no edge. Means this row complete 0. Next D. D to A edge is there. D to B there is no edge. D to C edge is there, and D to D is 0. Means D to A, D to B 0, D to C 1, and D to D 0. This is adjacency matrix. Convert graph into adjacency matrix. This is initial state, or we can write step 1. If this is step 1, then we can write step 2. In step 2, one vertex as a intermediate vertex. Means we have to find r to the power k. R to the power k. Means if k equal to 0, k equal to 0. K equal to 0 means there is no intermediate state. There is no intermediate state, means that is adjacency matrix. And within this step 2, we can take k equal to 1. If k equal to 1 means r to the power 1. R to the power means in step 2 there is one vertex as an intermediate vertex. One vertex is intermediate. By default, you can start from first A, then B, then C, then D. Means in step 2, vertex A as intermediate vertex, right? Vertex A as an intermediate vertex. Means using A, we can take transactions. That is r to the power 1. R to the power 1 or to find. Means one vertex as an intermediate vertex. Using A, we can take transactions. If vertex A has an intermediate vertex, then first row will get same value. First row will get same value because vertex A itself as an intermediate. Means this is 0, 1, 0, 0. Next from B, B to A edge is there. A is intermediate, B to A edge is there? No. Means B row, means second row also will get same values. Next, C to A edge is there? No. Then C row will get same value. Next, D to A edge is there and A is intermediate. Maybe this D row will get different value. If already 1 is there, then we can write 1. If 0 is there, then we can check. First, D to A is 1. We can write 1. Then D to B, previous is 0. D to A to B, you can take transition because A is intermediate. D to A to B. Means this is 1. Next, D to C, already 1 is there. D to D using A, is there any transaction? No. This is 0. This is step 2. Means K equal to 1. Next, step 3. In step 3, K equal to 2. K equal to 2 means vertex B as intermediate vertex. Vertex B as an intermediate vertex means vertex A and B both are intermediate vertex. This is Warshalls algorithm is in dynamic programming. In dynamic programming, each step is overlapping. And here K equal to 2. K equal to 2 means there are two intermediate vertices. Means we have to find R to the power 2. R to the power 2 means there are two intermediate vertices. And two intermediate vertices means previous plus new. Previous intermediate vertex is previous is A. Then A plus B. Here vertex B as an intermediate. If B as an intermediate, A to B transaction is there. If A to B transaction is there, then maybe A row will get different values. First A to A 0, A to A 0, A to B already 1 is there. Then A to C using B, is there any connection? Is there any edge? A to B, B to C, no. Then this is 0. And A to D, A to B, B to D you can take. Now this is 1. Next, this is B as a intermediate. B itself as a intermediate. B itself as intermediate means this row will get same values. Next, C. C to A or C to B edge is there? No. This row will get same values. D to A, A to B is there, right? But this D again, maybe D row will get different values. Here, previous D, first 1, 2, 3 are 1. Only 1, 0 is there. Means only we can check this one. This is D to D. D to D, D to A to B, and B to D you can travel. Means B is an intermediate. Means you can take D to D. This is 1. And this is step 2. Next, step 3, step 4, R to the power 4. R to the power 4 means there is vertex C as an intermediate vertex. And if vertex C is an intermediate vertex, and this is step 4. Step 4, K equal to 3. So K equal to 2 is over, then K equal to 3. And K equal to 3 means vertex C as intermediate vertex. If C is an intermediate vertex, then from C to A, C to B, C to D, is there any edge? No. Means this row, this matrix will get same. This matrix will get same. Means here R to the power 3, R to the power 3 equal to will get same values. Same values means this is 0, 1, 0, 1. 0, 0, 0, 1. Then 0, all are 0. And D already 1 is there. Right. The next step 5. This is last step. In step 5, k equal to 4, and here there are 4 steps, 4 vertices. 4 vertices means last is k equal to 4, and if k equal to 4 means vertex D as a intermediate. D as a intermediate. If vertex D as a intermediate, using D you can take transactions. Means using A, B, C, D you can take transactions. This is R to the power 4. This is last step. Dear students, this Warshalls algorithm and Flow algorithm is important for your external exam. Easily you will get marks within this example. Here in Warshalls algorithm, first A to A we can take transactions, A to B, B to D, D to A we can take transactions. Means the first is 0 here. A to A we can take transactions. A to B already 1 is there. Then A to C, A to B, B to D, D to C you can take transactions. This is 1, and A to D already 1 is there. Then next here B to A, B to D, D to A we can take transactions. B to A, B to D, D to A to B you can take transactions. Means B to B, and B to C also you can take transactions, and B to D already 1 is there. Means this is all are 1. From C to A, C to B there is no edge. Means this C row all are 0, and D value is all are 1 is there. This is called as last step. Means R to the power 4. In Warshalls algorithm, we have to solve this example up to this R to the power 4.